Today we are going to discuss the synthesis of a cam profile in which the follower is of roller type and executing a uniform acceleration motion. So the question is, a cam rotating clockwise at a uniform speed of 1000 rpm is required to give a roller follower the motion defined below. Follower to move outward through 50 mm during 120 degree of cam rotation. Follower to dwell for next 60 degree of cam rotation. Follower to return to its starting position during next 90 degree of cam rotation. Follower to dwell for the rest of the cam rotation. The minimum radius of the cam is 50 mm and the diameter of the roller is 10 mm. The line of stroke of the follower is offset by 20 mm from the axis of the camshaft. If the displacement of the follower take place with uniform and equal acceleration and retardation on both the outward and return strokes, draw the profile of the cam and find the maximum velocity and acceleration during outstroke and return stroke. So first of all, we have to draw the displacement diagram for the follower motion through 50 mm. Okay. So here the stroke length is 50 mm. So now I will explain how to draw the displacement diagram for a uniform acceleration motion of the follower. So first of all, draw the horizontal line. So from the question, S is equal to 50 mm. Theta O, that means theta outstroke, is equal to 120 degree. Theta R is equal to 90 degree. In between there is a dwell of 60 degree and remaining there is a dwell of 90 degree. Okay, so total 360 degree. So I am dividing this. So this much of portion is of 120 degree, that means theta outstroke, and after that dwell is there for 60 degree, again the theta return stroke for 90 degree, and remaining is again the dwell 90 degree. Okay, so next you have to draw the vertical line, and the dimension of this vertical line is 50 mm. Okay, so this is actually the stroke length of the follower. Next what you have to do is, you have to divide this portion into 8 equal parts. Okay, you are going to divide this into 8 equal parts. Okay, so this is your point 0, 1, 2, 3, 4, 5, 6, 7, 8. So divide this outstroke into 8 equal parts. So now from the midpoint of this divisions, that means here it is 4. Okay, so here it is 4. Draw a vertical line. Now again divide this vertical line into 8 equal parts. So I am naming it as A, B, C, D, E, F, G and H. Okay, now complete this line. Next draw this vertical line. Next you have to join this origin, that means 0 to A, then 0 to B, then 0 to C, and then 0 to D. After that you have to join this D to this endpoint. This will be a straight line, then E to the endpoint, F to the endpoint, G to the endpoint, and H will be the same. So this point will be J. Now you can mark 1 with this A. Okay, you can mark 1 over here, then 2 with this point, 3 with this line, 4 is this line, then 5 with E, 6 with F, 7 with G, and H with 8. Now by using a smooth curve, you have to join all these points. So after that, you will be having the dwell. Okay, so the profile will be like this. So again, after this dwell, in the question it is told that it is having a retardation. Okay, so again you have to plot the same procedure. Again you have to follow this same procedure for obtaining the curve for uniform retardation. Okay, so for that, again you have to divide this theta r into 8 equal parts. So this is 0 dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, and 8 dash. Okay, before that, I will name this each and every point. So this is starting from A, this is B, this is C, D, E, F, G, H, and J. So here, after naming these points, from the midpoint of this divisions, you have to draw a vertical line. Again, you have to divide this vertical line into 8 equal divisions. Okay, so I will tell you how to divide a line into 8 equal divisions, 8 or how many number of equal divisions. Okay, so suppose I would like to I'm drawing this line. I don't know the exact measurement of this line, but I would like to divide this line into equal divisions, say 7 divisions. Okay, for example, I'm going to divide this line segment into 7 divisions. Okay, so for that I have to draw a line at some angle, whatever it be, at some angle, but this is of known length. Okay, known length, let it be 7 centimeter. Okay, let this length be 7 centimeter, and I have to divide this line segment 1 centimeter each. 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter, 5 centimeter, 6 centimeter, and 7 centimeter. So this is not required. So this is the 7 centimeter point. Okay, so this is actually 7 number of divisions. Okay, so after that you have to join this to the end point. Then you can draw parallel lines with this line. Okay, so draw this parallel line, again parallel line, again parallel line, again parallel line, like this. You can have equal number of divisions. That means this is your first division, then second, third, fourth, fifth, sixth, and seventh. So this is how I can divide a line segment of unknown length into equal number of divisions by using a known length. So here, if you want to divide this line segment into 8 equal parts, you have to draw a line like this, which is having a 4 centimeter. Then you have to divide this 4 centimeter line of 0.5 centimeter each, join the endpoint of this line to this endpoint, then draw parallel lines. Then thereby you can divide this line segment to 8 equal parts. Okay, so this is your points A dash, B dash, C dash, D dash, E dash, F dash, G dash, and H dash. Okay, so Repeat the same procedure over here. Join this point with G dash, F dash, E dash, then D dash, and this will reach over here also, this 8 point. Then C dash, B dash, and D dash. Okay. So after that, you have to join this 1 with here, 2 with this line, 3 with this line, 4 is here, then 5 here, 7 is here, and 8 is here. After that, by using a smooth curve, you have to join. So this is how you can plot the curve for a uniform acceleration and uniform retardation motion for the follower. So now let us move to the synthesis of the cam profile. So here also you have to first draw the base circle. So here the minimum radius of the cam is 50 mm. So that is the radius of the base circle. So this is the radius of the base circle. So from that you have to draw the base circle. So after that you have to draw the offset circle. That because in the question it is told that the follower is offset by 20 mm. So after that you have to draw the offset circle. So this is your offset circle. That means from this center the offset is of 20 mm. Then you have to draw the vertical line which is tangent to this offset circle. Okay. So here we are using a roller follower and the diameter of the roller follower is 10 mm. This vertical line will cut the base circle at some particular point. So from that particular point you have to mark a 0.5 mm. Okay. So this will be of 0.5 mm, and with this A as center you have to draw the roller follower. Okay. So this diameter will be dia 10 mm. Okay. And next you have to join this A with this O. Okay. And with O as center and OA as radius, you have to draw the prime circle. Okay. After that you have to mark the theta outstroke, dwell, theta return stroke, and the dwell period in this diagram. Okay. So first of all the theta outstroke is of 120 degree. So from this OA, the line OA, you have to mark 120 degree. So this is 120 degree. So you have to mark 120 degree. After that 60 degree. This is 60 degree. Then after that 90 degree. This is 90 degree. And remaining is again 90 degree. So this is 90 degree. Okay. Since you have divided this 120 degree, that means theta outstroke, into 8 equal portions, here also this 120 degree should also be divided into 8 equal portions. Okay. So this is 0, then 1, 2, 3, 4, 5, 6, 7 and 8. Now you have to draw lines which are tangent to the offset circle passing through these points. Okay. So this is your first line which is tangent to the offset circle. Then second, passing through the point 2 and tangent to the offset circle. Passing through 3 and tangent to the offset circle. Like this you have to complete whole the lines. After that what you have to do is take the measurement from this displacement diagram that means 1B. Okay, 1B. Then from point 1 you have to cut an arc at for getting the point B. Then take 2C, place your compass at 2 and mark the point C. Measure 3D, place your compass at point 3 and mark D. Similarly 4E, 5F, 6G, 7H, 8J. After the dwell, so here it will be dwell. Up to this much of portion it is dwell. So after the dwell, 0-K, mark K here. Then 1-L, so 1 dash, so this is 1, 2, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash and 8. 1-L, 2-M, 3-N, 4-P, 5-Q, then 6-R, 7-T and 8-U will be the same point. Okay, so the remaining is dwell. Next what you have to do is, now you have marked the points B, C, D, E, etc. With these points as centers, draw a circle of 10 mm diameter. Okay, so with B as center, I am drawing a circle of 10 mm diameter. C as center, I am drawing a circle of 10 mm diameter. D as center, I am drawing a circle of 10 mm diameter. E as center, I am drawing a circle of 10 mm diameter, and similarly I have to complete till this U. Okay, now you are going to draw the cam profile. Okay, so you have to draw the cam profile such that all the rollers is tangent to the cam profile. Okay, so you can see that I'm starting out from here. This is tangent to the small circles, tangent to the rollers. So this is tangent to this circle, this circle. So by using a smooth curve, you have to draw the curve such that the curve is tangent for all the circles. So this is your required cam profile. Please try to practice this problem. Thank you.